Thank you very much for being here, for staying here. We are going to talk about synchrotrons and compact neutron sources. They are key for many applications, and right now in Europe they are upgrading to what's called fourth generation, and that is going to create many opportunities to companies and also for collaborations. So this session is going to be, I hope, nice and cozy for everybody. The speakers here will talk about the highlights of upcoming business opportunities in such facilities. So this is going to be 3 presentations, one after the other. And after that, we will have a short round table where you can talk to the speakers. So please just keep your questions to the second part of the session. Thank you very much. First of all, Caterina Viscari, please.
I should go there?
Oh, wherever you want. You have here.
Yeah, okay.
You can pass out. She's the head of ALBA Synchrotron. Thank you, Caterina.
Thank you, Leonor. It's a pleasure to be here today and to have listened to so many interesting projects. We heard a lot about big projects. Our is not so big as we have heard of many this morning, but it's a Spanish one, and this is very interesting for the Spanish industry. So ALBA is a light source. Its history is here. We started, in '93, the initial idea, but the approval was in 2003. In 2012, we entered in operation, and we have started the project, the design of the future of ALBA, ALBA 2, already 5 years ago, but we had the official funding approval just a few months ago, in September. And it was on the 9th of September where we had the approval of the funding for the upgrade and also for the operation until 2038, which is quite interesting to have this long-term plan for the future. So what is ALBA? ALBA is a synchrotron light source. So we accelerate electrons to 3 GeV. There is 270 meters of circumference. And around the storage ring, there are the beam lines, the experimental beam lines, where the light source, the light which comes from the electrons are used for matter, studying the matter. And of course, it's a national facility in terms of funding, but it's fully international in terms of use and partnership, and also of interest as an European facility. We are part of the LEAPS association of all the synchrotron FEL of Europe. And what we do is we have studies on life science. What you see here is the cell of one cell with the virus of the coronavirus. We can make tomographs of cells down to 20, 30 nanometers of resolution. We do a lot of experiments on materials, energy materials, and on advanced materials, quantum materials, spintronics, and many others. There are thousands of applications. It's interesting that the publications that are based on the public science, they are used as input for patents. We did a study in which we saw that the number of patents which are mentioning papers published with the studies at ALBA are 50% more than the number of the publications. So this is a real impact on innovation, not only on science, fundamental science and knowledge. And another very important thing, considering there are people here from industry, is that we have access also for industry. They come while the public, the academic access is competitive and is free. The access for industry is with direct contact, and of course you have to pay the access. But you see here the statistics on the fields of industry which are using us. The main one are pharma, but nanotechnology, chemistry, battery, health, cosmetic, and so on. So what are we doing in these next years is what we call ALBA 2. ALBA 2 means, as Leonor was saying, the upgrade towards a fourth generation. This means that we will change the storage ring, the main accelerator, to get an electron beam much more focused, which means that the light which is produced will be also much more intense and brilliant. And on top of that, there will be the upgrade of all the experimental beam lines, and there will be 3 more beam lines, 2 of which will be very long, which means that we will also build the new buildings, technical buildings. And the schedule, as you can see here, as it is now, is that from now until 2029, in parallel with the operation of ALBA, we will be building all the systems for the new accelerator and also for the new beam lines. And then and this will happen in the next 4 years. Then there will be 1 year of shutdown in which there will be the disinstallation of the system and the installation of the new one, 1 year of commissioning, and then again the operation. So you can see here that there is design and procurement for different systems. I will go now with some more details on these different systems that we are planning to procure in the next years. The first one is the accelerator, the storage ring. So we will have an accelerator which is 270 meters long. This means that we will need magnets, vacuum system, diagnostic, girders, all the infrastructure. We are keeping the same infrastructure that we are having, but the part of the accelerator is all new. And this means that here you can see what we want to do with the photon beam, going to a very much more intense photon beam. The accelerator system accounts for 70 million to be spent in the period 26-28. And here is the list of systems. And what we have now is that for some of them, we have been already prototyping. Some of them, I have been speaking here with companies which have worked in our prototypes. For example, you see there the girders, which just arrived some few weeks ago at ALBA, the corrector magnets, the injection pulse magnet. This is a special new design that we did at ALBA. And so it's a technology which did not exist. When I speak of magnets and of girders, and you saw the beam, how it is going to be much more intense, which needs much more resolution, which means we need more stability and all these technical solutions also for the magnets, which are smaller magnets but stronger magnets, means that we need to develop new technologies. You need to develop new technologies. And so this is also, and what I want to also to highlight, Fulvia was talking about the many projects which are in United States, but also in Europe. This process that we are doing is being done by several synchrotrons in Europe. Some have already done. SLS and Electra, SLS is already running in the 4th generation. Electra is in the process of installing the accelerator, but there are Diamond, Soleil, us, and then in the future also Petra 4, which will be there we are talking of a storage ring of 1.4 kilometers at 6 GeV. So the need of this system, which are a new generation also of magnets and of systems, is not only for ALBA, but working with us, you can also become competitive in the wider panorama. Then there are beam lines. You have seen we have now 14 beam lines. Some of them are working already since 2012, so there is a need of renovation, as also what Fulvia was saying. Of course, there is the part of renovating systems that are somehow old, and some part must be changed in order to be optimized for the new source. And here we are talking of a value of 44 millions. And here we will need, of course, optics, vacuum system, diagnostic, mirrors and station detectors, sample holders. A very important part is the data infrastructure and all the conventional facilities. Then there are new beam lines. As I said before, there will be 2 long beam lines and 1 more beam line with this less complicated beam line, this Kalima one. And then there is another beam line on which we are already working because we will move 1 beam line to another port. And this, you can see there, this photo on the right is the hatch for this beam line. And also here, I would like to say that these hatches, we have tried sometime to work with Spanish companies, but we never succeeded. We will need more hatches in the future. Please consider also this, which is not so difficult to do, but is also an important part, also because here hatches will be needed for many other synchrotrons. And when I say Kalima there, which is easier, is one of beam line in which we are thinking if it were possible to have a full procurement for the complete beam line. Working with us, but doing all the system of this beam line, which is not one of the most difficult or more innovative one, but is something that we will need, and that is also a project that could take care of more systems altogether. So this is another of our programs. And then there are also new buildings. You can see there this layout where there are the long beam lines, which will go over a small river. You can see behind our 2 speakers, the systems to bring the photon beam from the present building to the new one. So there are also constructions which need to be very precise, instability, technical system for the experimental hatches. And so this is another part where we will need your contribution. And this corresponds to 29 million. So here is the investment spending profile for the full period. I said before that we have the funding for 25 to 38. You can see the peak corresponds to the construction of ALBA, but then there is a continuous investment, as Julio was rightly pointed out before, which takes care of the normal investment that you need to run a complex facility. So we are talking for the next period of something like 170, 180 for the next few years, and then a continuous investment profile. And that's all.
Thank you very much. So as I said, the presentations are going to be very interesting, so please keep your questions for later on. Now we have Paul Harten. He is the Technology Transfer and Innovation Head of the Helmholtz-Zentrum Berlin für Materialen und Energie. That is HZB. I hope I said it right. And he's going to talk about the upgrade from BSI2 to BSI2+, and their plans and needs in short, medium term. So thank you very much, Paul.
Thank you very much, Leonor, for the kind introduction and the correct spelling of our name. And I'm very happy today to share a little bit of the journey of BSI to BSI2 and 2+, and in the future BSI3 today with you. So let's look at what our mission is. Our mission is actually including materials discovery, or better said, circling around materials discovery. And this is a very simple reason why we need BSI3, because we also want to have the nice features that were already shown in the first talk with a very precise beam. And so this is why we are also on the same road to Gen 4 and very high brilliance of the synchrotrons. So this materials discovery is not only big science, but it also requires a very big lab infrastructure for us in Berlin. So we are not only running this BSI2 facility there with around 100 scientists and operations, more than 100 operations staff, but we are also running a lot of labs to actually do to implement the mission that we have from materials to solutions. The reason is that we are not stopping at the analytics and the analysis of the materials using the X-rays and all the different methods that we have, but we are also working in applications. So it was already mentioned that there are industrial users from different branches of industry active, also using the facilities here in Spain, but also for us, this is very similar. But we are actually running 700 scientists, half of our staff, in most of them in these surrounding labs, and the minority actually at the BSI2. Whatever BSI3 will be, one thing is clear. There are lots of uncertainties in terms of timing and budgets, but one thing is clear: whatever it will be green. So we will have a lot of effort in the planning stage, but also in the building stage, to make sure that we minimize the environmental impact, that we save energy wherever possible, recycle things, do circular, whatever can be done. So that's one big thing that's coming. The other thing is, of course, we already heard this before in the first talk, that a lot of components for Gen 4 are still under development. So the same holds true for us, because we are coming after Alba 2 and after Petra 4, and we have the similar requirements to have new components, especially new magnets. There's one example on the upper left side, this orange and purple type of drawing there. That's a drawing of a new type of magnet that was developed and designed and patented by some of our guys. So the other thing that is needed is, of course, the typical equipment that actually creates the storage ring, which is the undulators, the optics, and the beamlines. And last but not least, also the sample environment. And we are using the BSIC project to bring forward all three of these things and take some new pathways and put in some of the work of our scientists to improve these components, together with you guys from industry who is actually going to be building the components. In terms of optics, I will take the liberty of taking you on a short commercial break right now, because we are supplying most of the synchrotron community worldwide with diffraction gratings. And so we are proud that our gratings are very popular in the synchrotron community and helping a lot of our partners from other locations to run successful storage rings and beamlines. That was the commercial break. Let's come back to the topic of today's talk. Why are we doing BSI2+? What is BSI2+? Well, we noticed that big projects like this take a lot of time and a lot of convincing with politicians, with budgets. So, and BSI2 is already more than 25 years old. So we are looking at equipment that can be breaking down occasionally and being in a difficult position to find replacement parts. So we have to modernize because the time until BSI3 will be operational will be in any way, whatever we do, it will be too long to keep the existing system as it is. And what do we modernize? So we modernized, of course, the software, the hardware of the storage facility, but that's not all. But we also modernize operations. We already prepare now for more flexible and more extensive beam time for industrial partners, because we recognize that with more and more application-oriented research, like for batteries, more and more battery-producing companies need our help to understand the atomic level of their batteries better. And we have to make way for that, and we have to accommodate quick access and regular access, which we already have as a director's time at this moment, but that's not a standard operation procedure. So as director's time, it's occasional. And we want to go further and make this more standard with BSI2+ in terms of operations. Now with BSI3, we actually, or essentially, we plan to turbocharge material discovery compared to what we have now at BSI2 and in the future, near future at BSI2+. This requires some investment. It will be more than €1 billion in today's money. So it will be a big challenge. We already heard about the technical challenges. But it is also an administrative challenge in the sense that we have to put BSI3+ on the national research infrastructure roadmap in Germany. Petra 4 is on it. We are not yet, but that's our next step. So we are preparing to get on that roadmap, which means there's some sort of commitment from the government that this project is getting a certain priority, and a certain priority in terms of budgets and funding. So that is a very important milestone. We are working on that right now. Of course, we are a member of LEAPS, so we are talking with our colleagues, not only from ALBA, but also from the other synchrotrons in Europe a lot. And with Petra especially, since they are very close neighbors. But we look at this in terms of LEAPS as a challenge of the whole community to get the Gen 4 to everybody and to work together on the infrastructure part and the components part. Well, let's go back for a moment. There's one important point here on this slide that the main thing why we are doing all this with the Gen 4, we have a chance to get 100 times more brightness compared to BSI2 and 1,000 times more focusability of the X-ray beam down to 10 nanometers, which is it's a different world for anybody who's in nanotechnology. So, and this is really the game changer why we are all spending a lot of effort and a lot of money and a lot of convincing to reach Gen 4 for everybody in Europe. Now, why we are focusing on soft and tender X-rays with our BSI3 project? We focus on that not only because a lot of our application-oriented research has good room for applications in that area, but also because worldwide availability of beamlines is a little bit on the lower end in the soft and tender range. And so we feel that we should contribute to fill that gap and make soft and tender more available and bring that to Gen 4 with nicer beams and better analytics capabilities. And we see that doing that, our catalysis and battery research will benefit a lot, but also the life sciences in some areas. But for us important are also quantum materials and also environmental sciences. So these are a very short summary of the application-oriented research areas that we are active at. And that concludes my talk. So thank you very much for your attention.
Thank you very much. Thank you, Paul. Yes, thank you. So our next and last speaker for this session is Mario Pérez. He's Executive Director of ESS Bilbao, and he's going to talk about the Argitu project and some other plans in ESS, ELENA, neutron sources, the actors involved, the plans, and so on. So thank you very much. Thank you, Mario.
Thank you very much, Leonor, and thank you for inviting me to this talk. It's a pleasure to be here. So today I'm somehow wearing two hats. so as the director of ESS Bilbao, in which I will give you a brief overview of what is the status of ESS and our contribution to ESS, and then what could be the opportunities that lay ahead for ESS. And then I will change my hat to the chair of the ELENA Association, which is the European Low Energy Accelerator-based Neutron Facility Association, in which we are proposing this next generation of neutron source, which are called high CANs, no? High Current Compact Accelerator Neutron Source. So, I see a lot of known faces, but for those of us of you that do know ESS Bilbao, so we are a public consortium between the Basque government and the central government, which was established back in 2006, a long time ago. First, we were leading the candidature of the European Spallation Source to be built in Spain, in the Basque Country, but after the decision to be built ESS at Lund, then our mandate changed to channel and to deliver all the Spanish and Basque contribution to the European Spallation Source, and to use this knowledge, to leverage this knowledge to become a center of development of accelerator, neutron, and target science and technology. We are a small organization. I mean, we are just 55 employees around. So I used to say that we are few, but we are young and very, very brave. So we are based at Bilbao, at Zamudio, very close to the Bilbao airport. We have our offices and our R&D lab there. Then we have an advanced welding facility in Vitoria, some 100 kilometers from Bilbao, in which we have an electron beam welding and advanced welding, a brazing welding machine. And then we have one of our division at Madrid, in the target division. As I say, we are the Spanish institution responsible to deliver the in-kind contribution to ESS. I'm sure that all of you know ESS. ESS is the European Spallation Source. It's an ERIC, a European Research Infrastructure Consortium, which is financing, I mean, there are 30 member countries, among them Spain, which are financing this big science infrastructure, this neutron source, which will be the brightest in the world once in operation. So basically now the project is going through the installation and commissioning of all the components, and it's expected that it will start operation in 2028. The beam power currently is 2 megawatts with an energy of 800 megaelectron volts. And just some months ago, they were successful in having the first beam through the accelerator, and now we are all working together to have the so-called beam on target, which is expected around April, May next year. Our contribution spans all the machine. We have contribution in the accelerator, in the target, and one of the instruments. The accelerator contribution is already finished. We provide one of the transport line, the medium energy transport line. We provide as well all the RF power system for the so-called whole LINAC, I mean the RFQ and the DTLs. The target is as well finishing. I mean now the integrated target commissioning that is called is being done. So we provide the heart of the machine, the target itself, and which is a rotating target wheel. And then the instrument, which is now in our main activity for ESS, which is a time-of-flight backscattering spectrometer, and we are now in fabrication and starting to deliver and install the components, and we expect to start the cold commissioning sometime end of next year, beginning of 2027. And I think, I mean, some of you probably attend the conference from Mirko. For the construction, there are not major opportunities ahead, but now there is a negotiation for the operation and development plan. This is just a plan. It's been negotiated at the council. We have just arrived from the council yesterday. And basically, just to give you an idea that I think Mirko also presented to you that there is a proposal to have a development plan for the 10 years starting in 2028 to invest around 30 million euros a year. And basically, this is to get to the initial ambition of the facility, which was 5 megawatts, 22 instruments. No? to upgrade with 7 instruments and also to upgrade the accelerator to 5 MeV. Then I changed my hat now to the chair of the ELENA Association. ELENA, we are proposing this high-CANS concept, which is a high-current compact accelerator neutron source. Probably you have heard about the CANS, which are there for already several decades, which is compact accelerator neutron source. This LENS in Indiana or RANS in Japan. These were small sources in the order of less than 1 kilowatt power that were normally installed at universities or small labs. But now with the development of the accelerator technology, and in particular with the compact design of target moderator and reflector, we are able to propose designs with compact sources. We use stripping reactions instead of spallation. We just limit the energy at 70 MeV. And then, depending on the project, we are talking about 10 of kilowatts, and then neutron flux in the order of 10 to the 14, 10 to the 15 neutrons per second. And here, there are several actors involved. Jülich in Germany, they are proposing the high brilliance source. ICON from France, from CA and LB. We are proposing Argitu. There is also a proposal from Italy, Saraf in Israel. And basically, this came out of now there is a lot of discussions within Europe of how the future network ecosystems will be. Now we have the traditional research reactors that are being closed, and then the ILL, which is been discussed whether it will continue until 2033 or will extend it or not, and then ESS will come into operation also in the next decade. So there is a sort of earthquake within this neutron ecosystem, and these high CANs are seen as a sort of next pillar to support the development of the neutron ecosystem in the future. This is one of the conclusions of the LENS vision landscape exercise, and this LENS is similar to LIPS. It's the association of the main neutron source in Europe. And then very recently as well, ENSA, which is the Neutron User Association in Europe, as well has written a position paper in which they identify these high CANs as the source that could become an important pillar for the neutron ecosystem in the future, mainly to reduce centralization into the big facilities like ESS, ILL, ISIS, or PSI. ELENA, we established ELENA in 2020. Basically, what we do is try to cooperate across the different fields, technical fields, in the development of these high CANs. So, we have FENS, ESS Bilbao, IFE in Norway, Jülich, LLB, LNL, Mikrotron Saraf, and Uppsala University. And here, each of these institutions are proposing high CANs facility. In the case of Jülich, Germany, they are the most advanced one and the most ambitious. They were proposing the high brilliance source, which was much a bigger project than this. But now they are pushing for the construction of this called HBA's phase 1, which basically is an accelerator to build the first phase of the HBA's fully fledged, which is a 20 MeV accelerator, 100 milliamp, and then with a neutron yield of 10 to the 14 neutrons per second. I think this has been commented by my previous speaker. They have pretty good news because in July they were included in this roadmap of the federal ministry and were identified as one of the priority infrastructure to be built in the future. And of course, it doesn't mean that the finance is secure, but if you are not in this list, it's quite difficult. Then the project from France, ICON, they are also proposing a staggered approach with a phase 1 accelerator up to 25 MeV, 80 milliamps, and with 6 ports and 6 instruments, and then an upgrade to add a second beryllium target station to add more instrument. I mean, what is very good of these HiCANS projects is that they are modular and scalable. I mean, you can start small and then upgrade the facility to be more ambitious. And then Argitu, which is our proposal from ESS Bilbao. This is a 30 or 40 MeV accelerator, 32 milliamps, and up to five instruments. And we are also talking about an investment in the order of 100 million euros over five years. No? And these other projects that are smaller, but for example, in Sweden, they are already starting to think what kind of compact source they would like to propose and how also to consolidate and to further strengthen the neutron user community to be able to use or get more out of the use of the ESS, which is being built at Sweden. No? And then the project of Mirrotron, which is more a chance for industry, I mean, to irradiate some of their components. So Argitu, just to give you a little bit more detail, as I said, this is an accelerator, 40 MeV accelerator. So you have there the accelerator, then a compact target, and 5 instruments. And now our main focus now is in discussing with the user community, neutron user community, which are the best neutron suite for this kind of source. And we are now more or less agreed that the diffractometer, spectrometer, SANS, reflectometer, and also an industry imaginary radiation station will be the best instrument suite to take the most out of the performance of this kind of source. But we are also working with our colleagues from Jülich and from France, from CA and LV, to build what we call a HiCANS platform, which is basically a first phase or a demonstrator of these kind of facilities. This is to be built in Bilbao, in Zamudio. And basically what we are doing is, I mean, ESS Bilbao is providing the accelerator, which is already there. I mean, we are now at the phase of high voltage conditioning of the RFQ, and then the target will be brought by our German colleagues, and the instruments by our French colleagues. So, I mean, as I say, we are providing the accelerator, the ion source is up and running, the RFQ is already there, the bit pool tuning and the bit pool and the tuning is complete, and we are starting now the high voltage conditioning. And then also we got a Klystron from our ESS colleagues, and we have all the elements of the RF power system, and has been already successfully passed the integrated test, and we are starting the high voltage RF conditioning of the first the couplers and then the RFQ. This is the target of our German colleagues. I mean, they are using a tantalum target, and probably we will change this to lithium, because lithium provides a better neutron yields for 3 MeV protons. And then our colleagues from France, they will provide the Hermes reflectometer and one diffractometer. And also they are interested in testing their beryllium target, because it's the target that they will use in their ICON project. And I think this is all I want to share with you. So basically, from the ESS Bilbao perspective, we are delivering, I think, successfully the in-kind contribution, Spanish and Basque contribution to the European spallation source, and we are also heavily involved in the development of this HiCANS-based neutron source, which is the next generation neutron source that could be one of the pillars of the future neutron ecosystem. So, thank you. Thank you very much.
Thank you. So thank you very much, Mario. Actually, you had 5 more minutes, but you did it so quick. The watch, we have a watch here, and it was not. Yeah, I know. I'm sorry. I didn't want to interrupt you.
Okay. It's
okay. So now we have like 40 minutes, a bit less, because I will have to go to the auditorium after this round table, and I would like all of you to join us in the goodbye part of this nice event. So I have seen that there are not many people here, so I really ask you to participate. So please, we have very nice speakers here. They are very friendly, and they really want to ask to answer your questions. So please, if you want to ask any question, just raise your hand. If not, I have a lot of questions. No? Okay, please.
So there is a full scope of new synchrotron facilities coming in Europe. Of course, 4th generation, all of them. What is the differential factor, the competitive advantage you have, you think your proposal has with respect what is going on, okay, Soleil, Diamond, Alba, Petra 4, that is very ambitious, Electra, second stage, all of them. What's the added value is for sure the facility itself, but the differential value, what it makes it different, more sexy?
Well, first of all, it's ours, so that is the most important thing, as you well know, because you built Alba. I would say that it's the same as when all the synchrotrons started and when Alba started. We started with only 7 beamlines. And of these 7 beamlines at the beginning, there were some which were clearly also in other synchrotrons because they were the ones with an already existing community somehow that every synchrotron has to have. But then there were some special beamlines where really they were different. And there is tomography beamline. I show the cell there. There are few in the world. And the Alba one is the reference one. Or otherwise, the beamline which is dedicated to study magnetic materials, which can do together scattering and absorption. This is also special. It's a beamline that does not exist in the world. And we get their users from all over the world. So this was the concept, and it was very successful because you have the basic, the beamlines with already a strong community, but then something which opens door and creates new communities. For Alba 2, of course, more or less we follow the same concept. What will be very the flagship are these 2 long beamlines. The fact of having the possibility of doing long beamlines gives you an increase of the resolution, a better resolution. The resolution goes directly, is inversely proportional to the distance between the source and the sample, and also a larger coherent fraction of the photon beam. And this, we have with respect to other synchrotrons which have all the surrounding already filled, we had an empty space. And that is a difference which makes us now more competitive because we can fill up this empty space with these 2 long beamlines with a lot of space in the experimental area of each of these beamlines, and on top of that also the possibility of building around these beamlines new institutes of research. I didn't mention here, but there is also already a project which has been approved and is in the design phase of what is called InnoFab, which is an institute for research in chips that will be mostly is linked to the fact of having Alba, and in particular the long beamline for material science, and is open to innovation. The InnoFab, the Inno comes because of innovation. So this fact of having, first of all, the land, then the possibility of doing these special beamlines, and the possibility to grow on top of these beamlines other institution. The other one is the proposal of having an institute which is to be dedicated to One Health, life science, to have a BSL3 lab where you could work with virus or the peste porcina, as you
Pork pest, no.
which is one of our worries in this moment in Spain. I mean, to have also this special development, which are not anymore only X-rays, but is more than the X-rays. And so I think this is the important thing, is that we are working in having the capacity of developing multimodal instruments where not only you offer an instrument, a special technique to the user, but you offer a set of instruments which altogether can solve complex problems. And here is what ALBA 2, the real reason of ALBA 2, apart from making this very nice beam, is that to have more capacity for solving complex problems.
Thank you very much, Katerina. Okay. Okay, so then,
So
please,
the question was not only to
everybody?
ALBA, but BSI3?
Yeah, I'm happy to.
What makes you sexy in front of the big brother?
Yeah, for that point, two words come to my mind: application and cooperation. And in both of these areas, we have a very unique setup in Berlin. We have, in terms of cooperation, we have basically our founding fathers of BSI, the PTB, Physikalisch-Technische Bundesanstalt, the National Institute of Standards of Germany. And they are not only heavy user, but they are operating their own metrology light source, which is operated by us, but they are using it for very unique projects that nobody else in the world can do. And they have their own beamlines. They also do special things there. We get beam time on those beamlines as well for other users. And this has been a great symbiosis. And another type of this organizational or symbiosis is with the BAM, the German Institute of Material Science and Research. And it's also a government institute specializing on materials testing, and they also have their own beamlines and do special things there. And we do projects together with them. And now we are also with industry partners. We are doing similar things. So we are working with industry partners, for example, in catalysis and green hydrogen. And these guys, industry partners, they themselves, they have no relationship to synchrotrons, but through the cooperation with our scientists, they get to use this facility and get the results from it that they need to build new catalysts and new catalytic furnaces and systems. So our partners are now going next year in the prototyping phase of a new product that they developed with know-how from our scientists, also occasionally using synchrotrons. So that leads me to the second word, application. We are not only cooperating with unique partners, but we are also building, and we are providing and using and having very in-depth expertise in certain areas. For example, let's take solar cell as a second example. I just mentioned the green hydrogen, but solar cells has been our flagship research for 20 years. We have world records, several stuff. So everybody knows us in the solar research, and the solar scientists, they're testing their materials for new solar cells at BSI. And the closeness of BSI and the solar cell research, both world-class facilities, that makes very quick and easy progress on the materials development side. And this is why we are calling it a research development facility, materials development or materials invention facility even, because of the closeness of specific applied research expertise combined with the specific analytic tools provided by synchrotrons, and Gen 4 even better than what we have now. This makes a unique setting for quick and decisive progress using multidisciplinary elements and competences in one location. And that is then complemented by my personal thing that I'm working with a larger Berlin University community, personally on the level of startup creation. But we also have a very big network of joint professorships with all the big universities in Berlin. So all the Berlin research community is also connected with our BSI and with all the other resources we have. So this is also very, very powerful, because we not only get a lot of very talented researchers, but we also get great ideas for innovation, out of which too many today are still lost because we have not enough support for innovation. And that's what I'm working for. And if I'm successful, we can also make actually innovation a third pillar in addition to research and teaching or education. This is definitely one goal that I share with other people who are interested in innovation in Europe, because in all of Europe we have the same challenge, that we are losing a lot of good ideas because we have no ecosystems to really grow innovative ideas from the bottom up. I know Alejandro is working on that very hard all the time as well with his team.
He's there.
Yeah, there he is. And fortunately, there are quite a few people out there in our work, type of work, who are thinking the same way. So even in the European Commission, there are some people. So I think we have a chance. We should take it.
That's great. Thank you very much, Paul. Mario, would you like to add something, anything?
Well, from synchrotrons, that's not my field. So.
But if I may
Sure.
add something about, I said before about ALBA, you said about BSI. We are both in LIPS, in particular BSI or HSB will be the chair in 2027.
Right.
Now it's vice chair.
Right.
And I think the fact of having created this LIPS association, which now has become an ISBL, which makes our voice stronger in Europe, is really important also in view of what the industry can do for us, but how they can develop together. And I want to mention that there is a recent document that is the LIPS Technology Roadmap, where all the different technologies that are needed in the next, let's say, 10 years have been well explained. And this is a document that we should distribute also in this forum of the industry, because it's something that puts together all the needs of synchrotrons and FELs in Europe, but they are the same in the US, would be in China if they didn't do everything by themselves. But it's something, this document explains very well where we are and how we are in a collaborative competition.
Yes.
No? Because of course, each of us wants to excel, especially in something, but we collaborate very much. Yes. This is very, very important for the industry also.
Great, thank you. So that was going to be one of my questions. I understand that you are doing the same approach to science, but there will be different needs for the components, for example, for ALBA and for BSI, or the needs, the machine will be, the component can be built for ALBA and then directly built for BSI without changing any specification. I know it's a tricky question.
You want to answer? Or
you can answer, both of you.
Yeah, I would say that our scientists are very proud that they have their own concept and their own plans.
Okay.
But I think principles of these new equipments, principles of new magnets, of new undulators and stuff like that, they can be transferred, they can be even tested by the first one who is pioneer, maybe Alba too, and do a lot of, go a long way to make these things easily adaptable and easily implementable in Petra 4 and BSI-3. So
Yes.
there is a synergy, but it's still everybody has their
Something to
own
do.
specifics.
Yes, I mean, first of all, you have the length of the rings is different, so you cannot really put the same elements, but similar one. There are some where you can really do, we did, in particular BSIFS with the RF cavity, the third harmonic cavity, we did the design, Francis is there, and there was a company which was a Spanish company, the prototype, and the prototype has been tested in BSI-2. And now we will build the other 4 cavities on the prototype, which was tested in BSI-2. So we really, whenever is possible, we develop a system that can be used. But if not the system itself, at least the kind of technology and of technological solutions, this for sure is shared. And this is something that we do also with the proposals we present to the European Commission. We have been doing a very successful project which is called BSIFS202, which is now finished, where we have developed different systems for the accelerator, for the synchrotron, not only accelerator, but also detectors, mirrors, gratings. And then now we have just submitted a new one which goes in this direction, develop together system that then can be used with the needed tuning in the different systems.
Okay, great. And Mario, does it happen the same in Elena?
Yeah, I mean, indeed, one of the reasons to establish Elena was specifically that, no? To share technology developments, to share experiences, and trying to develop technology roadmaps or technology development programs, common ones, so find synergies in the way that there are certain technologies, for example, these compact and high power targets, this coupled design of the moderator with the instrument that it gets. It's key to get the performance of this neutron source. It's one of the differentiated elements. I mean, this compact source can use the neutrons much more efficiently than an spallation source. You get much less neutrons, but you can use it more efficiently. The point is that, I mean, Elena is at the moment still rely on voluntary contribution. No? Sometimes this make it difficult to keep momentum and to align national priorities. I mean, any of us has our own project, and we try to share the different developments, but it still relies on a voluntary effort, no? But yeah, for sure. I mean, and this will of course benefit as well industry, because if we are able to develop technologies that are interoperable and that are can become somehow repeatable business opportunity. I mean, what you do for one of these HiCans, you can just transfer to other HiCans projects and then make broaden your market and make a repeatable business opportunities for the deployment of this source in the future. No?
Okay. I have 2 more questions, and then I will ask you to ask more questions. Now I understand the opportunities for the industry, but how can the industry access those opportunities? How do they contact you? Will you, don't know, put some tenders on the table, or how can they be part of these new developments? Mario?
Well, in our case, I mean, we are at Elena normally invite companies to our general assemblies, and then we have also every year every 2 years we have what is called HBS workshop, which is organized by our colleagues from ULIC, and then we have a special session with industry. And then we organize at Bilbao, together with BC Materials and other perks in the Basque Country, the IMO conference, and with you.
Yeah.
I mean, you are part of the organization, and we devote just a full day to industry. No? We want also to, and I guess this is important as well for synchrotrons, and I mean, trying to also push more industry as users, not only as providers, right? I mean, of course, as a company, you would like to see the business opportunities of these developments, but it's also important to show that these kind of machines are also of use for industry, no? So, and I mean, of course, you can try to build something more formal, no? A sort of more formal engagement with industry, and this, I mean, probably you can do it through joint R&D calls to develop pilots or something like that, no? But in general, at the moment, it's more, Elena is more a sort of platform to share technology roadmaps, technology developments of the different actors within Europe, and then if a more long and stable framework could be established, this could be really become more in a sort of industrial platform, no?
Okay. Paul?
Yes, we have, let's say, a different picture regarding single huge projects like BSIFS202, where we have a typical stages of tendering that are being done according to public procurement, because we are a government-funded institute. We have very strict rules, up to how many euros we can just order things, up to how many euros we have to have a national competition, and above 200,000 there's a European tendering. So that's very clear and very transparent. Everybody knows about this. But we also have additional channels like you just mentioned, Mario. We recently, 3 years ago, founded Helmholtz Innovation Platform with 5 Helmholtz centers, and 2 of them are big synchrotrons, Petra and so DESI, and HZB, Petra and BESI. So Petra 4 being on the roadmap, and us with BESI 3 and BESI 2+ entering the roadmap and entering the serious planning stages. Within this innovation platform, we are going to support each other. So we are going to help each other not only with experiences from the designs and from the later prototyping and so on stages, but also with bridging downtimes. When Petra is being switched over in the same infrastructure from Petra 3 to Petra 4, it will take 1 to 2 years to actually accomplish the switch. And we will help DESI bridge the gap and take care of some time-critical projects for them. And also now, at this moment, within this innovation platform, we are open for any kind of industrial partners. For example, we have one partner who's actually a metal manufacturer building specific alloys that are important for magnets. And they recognized this opportunity, and they joined our network, which is for free, so anybody can join. And with joining our network, it's called HiX, joining the HiX network, free membership, you're in the loop, and you can get regular newsletters and information what we are thinking about, what we are doing in terms of new developments, of new access modes, of new equipment that we may need in the future, and so become part of our community, and then you are in the loop with Petra 4 and BESI 3 with one membership. So
That's great. Thank you very much. And about ALBA?
Well, at ALBA, we also are a public institution with very, very strict rules for the procurement, of course, which makes our collaboration with speaking to the industry not so easy sometimes. But there are some things that are being done at European level again. When I mentioned before these two proposals, one finished and one just submitted, they are in the partnership. There are also companies, and there the companies are really co-developers. And this is done because the calls from the European Commission have allowed that, which is very positive. I think it would be great if we could do something like that at the national level. But I invite also here the companies to consider also these possibilities. It was very useful in the past, in this Leipzig-Nov, where I make an example. We wanted to develop mirrors. Mirrors are a certain kind of mirrors are done only by one company in Japan, and then we wanted to have also in Europe some company able to produce mirrors. And then we could team up to make this possible. It's not yet producing the mirrors, but it's something that it would be good to have the flexibility at the national level of really working with the industry to develop together things. Because what we need is something that is not that you can buy out of the shelves. It's something that you have to develop. And we need to speak the same language. The ideal thing would be to have someone from the industry who really could work with us, as in this case of these European projects, where the idea is great, the volume is not so great because it's small. But we should go in that direction if we want to make Europe really competitive, Europe, or in this case, Spain, really competitive in the industry. Just to mention something, in China, the industrial users can access all the research infrastructure for free. Of course, it's a different regime.
Yes.
But this helps because you really have the possibility to work with the industry, and they really develop together. So
yeah. I mean, in our case, we are also public, and of course, to say it softly, no, the public procurement laws are not the most
yes.
easy ones to allow for this co-development, and also, I mean, and it will be very, very, very beneficial, no? Because at the end of the day, if the companies can enter in earlier stages, they can somehow influence, no, realistic specification, give innovation manufacturing approach, but the problem is that it's difficult. And then when we try to do this, I mean, you can do it, but then the law says that if you do that, you have to provide all the information that has been developed during this phase to all of the tenders of the next phase. So for the companies, it's not very interesting because somehow
Yes.
they don't have this competitive advantage anymore. No? So they made the effort during the process, but then they have to open the knowledge to all the rest. So,
or
I mean,
even they cannot apply to the cost
sometimes,
of tender.
yeah. Under certain circumstances, they cannot apply. Yeah.
Yes.
So it's not easy, but for sure could be very, very beneficial, no? And will also shorten the development cycles and get better engineering solutions, no?
That is really, really interesting. I'm going to say I'm sorry in advance because I know that I sent you some questions that they may be asked, but I have another question that is outside that. And that, well, I have seen that the public is not very, there are not many people right now, but I know that there is another parallel session about fusion. So we have the big elephant in the room, fusion, a lot of money put on fusion, a lot of interest in fusion, and there are many capabilities for the companies that can be applied to your facilities and also to fusion. Do you think that there are enough players, enough industry to provide for the big market that is that is coming in the following years, or shall the companies maybe open their their expectations or their businesses to provide for you? I know it's a tricky question. I really know it.
That's a difficult one, but I mean, first I think that I mean we are working also in Fusion. I mean, we are applying the knowledge and the skills that we got with ESS and neutron sources, and I mean, most of them are applicable to any. And we are working for some of these fusion companies. But I will say that first, there is a promise there, you know, and we have to see if the promise will be there, because, I mean, fusion, all the people say that, no, when I talk with friends and say, oh, fusion energy, they say, yeah, yes, this is that it's always 20 years ahead, right? So now industry startups and say, no, we can do it faster, and probably, of course, with a startup mindset, I mean, they are much more agile, but still there is a lot of challenge, not only technological, but that even the physics behind that needs to be overcome, you know.
But anyway, let's add quantum to the equation. That they always will need vacuum and cryogenics and.
So I think this will accelerate, and of course, this sounds very well to the funding entities, because somehow it's the industry which is saying, okay, we can do it, and we will do it, and we will invest. There is private investment, so this is all very good. But in terms of how the industry should prepare for that, will depend on if the promises that are on the table will really be met, no? And on this, you can have all the kind of opinions. I will not give mine here, but yes, this is a very big market, and I mean in Germany, they are really investing on that, in US, and well, we'll see, no? Yeah.
Would you like to add anything to that?
Yes, I would like to add that I had a meeting yesterday with 2 fusion companies, and one of them actually asked if some scientists from Berlin could come over to them and work for them. So I see the big vacuum coming, where these companies are sucking up anybody who can spell physics to work on their fusion projects. Because, as you said, the projects are so big, and there are so many thousands of people needed who are not there yet at this moment, in the right position. Yes. They are there, but they are not in the position where the fusion companies need them. So I see this coming, that there is industry is starting to realize that if they are successful, they will have a very big challenge. Not only to develop all the stuff, but to find the people to do all the work.
Yeah. Katerina?
Yes, it's like with AI now. There are companies which are taking the people, our IT people. They are really. There is a big competition from the private sector on some fields, and this is one. And of course, I mean, I think what we offer also to the fusion development is the fact that we can help in the development of materials or tests. Is not if BSIFS202, of course, which is fully dedicated to that, but what is done in the neutron sources, but also with the X-rays. I mean, we have participated in the preparation of the fusion strategy in Spain, and the part of what synchrotrons can offer, for example, for the development of the superconducting materials, and this is essential. So we are there also to participate in the fusion, as we are for the quantum or for all whatever needs better understanding of the performance of matter at the atomic level.
Yeah, and we are not talking about health and all the medical, yes.
Of course.
That is also a big development. Okay, so we have 2 more minutes. Does anybody want to ask any other question? No? Fulvia? No. Okay, so I would just like to say to you that there is no big science or small science. There is science industry. So you are not small. Alba is not small. Your center is not small. ESS Bilbao is not small. It's science, and there is an industry that helps you to do science. So we are all together in this path. So thank you very much. Thanks also for the audience. And let's go to the other room, to the auditorium, to say goodbye to this nice event.
Thank you.
Thank you.
Thank you, Leonor.